Welcome back to nutrient management, second class. Today, we're going to talk about soil tests, how to read a soil test, what all the things mean on there, a little bit about how we come up with the recommendations at the bottom of the soil test. And then we're going to dive into phosphorus in particular, and talk about the phosphorus index, which is the risk assessment that we will use in nutrient management planning to determine the risk of losing phosphorus from your fields. So for every field on your farm that's in your plan, we'll be calculating a phosphorus index value to determine what the risk of losing phosphorus is from each field. And the level of risk will determine, to some extent, nutrient applications. So if you are in a situation where the risk of phosphorus loss is really high, then it may mean that you have to reduce the amount of phosphorus that you're putting on those fields, okay? And your computer program that we're using, GoCrop, will calculate all that for you once we put everything. All right, so like I said, get out a soil test report, take some notes on it if you're interested in writing some of this down, because there is a lot of information on a test. And I would say most people kind of look at it and say, I don't know what to do with this. I don't know what this means. There's a lot of information here. You know, how do I use it? So this is a soil test report from the UVM lab, and every lab's tests look a little bit different. I think most people in this class will have a UVM report, but they essentially kind of show the same things. You know, a lot of them will have this nice little table or graph at the top, which, you know, shows you visually kind of the level of macronutrients in the soil in that field. So that's kind of a nice thing, just to get a quick look at, you know, are the phosphorus levels on my farm high or low? Are they excessive? It also shows potassium and magnesium. So you can get a quick look at, you know, where your field falls with just those three macronutrients, okay? So you can see there's low, medium, optimum, high, or excessive. Ideally, you know, you want most of your fields to be in that optimum range, obviously, right? That makes sense. Optimum means optimum. So if you're there, you would assume that that is a good level of nutrients to be able to supply your crops with what they need. And that's exactly what it means. So if you have low values, what that's telling us is that if you add nutrients to that field, the one that's low, the chance of seeing a crop response by doing that is almost guaranteed, right? Almost. So if it's low, adding something to that field is going to give you a pretty good return on investment, okay? If you add fertilizer or manure to fields that are at optimum, you're probably just going to maintain the levels of nutrients, and the chance of seeing a crop response kind of goes down, right? So fields that are low means if you add what they need, you're probably going to see improved yields, probably going to see improved quality. Once you get into the medium category, that chance goes down, right? So there's a medium chance that you'll see a crop response. Optimum, there's less of a chance. If you're in excessive or high, why? Why would you add more? Okay, you already have way more than enough there. So you're not going to see that same return. So when you're looking through your soil tests and you see a bunch of fields that are low, you know, you might say, well, that makes sense. Those are the ones that are 5 miles from the farm, right? Or if you see ones that are excessive, you might say, well, that makes sense. That one's behind the barn. or that was a night pasture for 50 years and, there was a lot of manure put there. So a lot of the times when you see your soil test, it'll probably make sense. You'll say, well, I haven't put any manure there for a while, or, we've had a lot of manure there. And so then you kind of have to decide where to invest, right? So should you keep putting what you have at home, those manure resources, on those fields that are really high, when you have fields that are really low? And that's, in some ways, it's kind of up to you to decide where you put all that manure. But within that, there are obviously some regulatory requirements that we'll be having to pay attention to. So as an example, if your soil test levels for phosphorus are high and excessive, then when we run the P index that I was talking about that shows risk of phosphorus loss, it might say that the risk is going to be high on that field. Okay. And that may end up, resulting in you having to put less manure on that field. Okay. And putting that manure that you would normally put there somewhere else. A lot of fields that tend to be high, there's usually some on every farm. They are usually the ones behind the barn, or, a farm you're renting that used to have a manure pile there, or something like that. Potassium, usually fields up here in this area, we see a lot of low levels of potassium. Okay. And unless you're on clay soil, like heavy clays, potassium is really prone to leaching. So it's lost really easily from certain soil types. So you can have instances where the phosphorus level is really high, but your potassium level is really low, even though you're putting manure there regularly. And again, that's because the potassium leaches out of the soil and phosphorus doesn't, which is also why we have, issues with phosphorus building up in the soil, and we don't usually see that same thing with potassium. Okay, now some people get freaked out here about the magnesium. We'll see a lot of fields that are high or excessive, and people will say, well, I've never put magnesium fertilizer on it all my life. I don't know why that's so high. Well, some soils in Vermont are just naturally high in magnesium and calcium. So if you're, over in the Lake Champlain Islands, I live in Alberg. It's all old ocean bottom, and there's a lot of clay and a lot of calcium in those soils. So the calcium levels in those soils are off the charts. And when you move to some soil types, some of them that are up here, you'll just have really high levels of magnesium. Okay, so it's not something you should get really worried about. You can't do a lot about it. What you really need to be worrying about is if your magnesium levels are low, okay, because it does really impact the other nutrients. And if you're grazing cattle, it can also cause metabolic issues, especially in the spring. So if you've ever heard of grass tetany before, that's a result of low magnesium levels in the springtime. Okay, so if you do see a magnesium recommendation on your soil test, you shouldn't ignore it. It's, something that you need. All right. So if we get really close here to the screen, you can see the next line down there is the soil pH. And I think most people know what pH is, right? It's the sort of acidity level of the soil. And most crops do best at pHs over 6. Some crops do best with pHs over 6.5. In the minimum for most farms that are taking this class, unless you're growing blueberries or cranberries, your pHs need to be above 6. Okay. I used to say, oh, it's okay if they're a little below 6 if you're growing corn, but the pH of the soil, it impacts so many other things that it really is in your best interest to get that pH up over 6. Okay. If you're trying to grow clover, white, red clover, bird's foot trefoil, alfalfa, any kind of legumes, soybeans, the pHs need to be above 6.5. Okay, and ideally really 6.8. So if you are, if you only have grass in those fields, and as I talked about last week, and I'm sure you all remember every word that I said, I said, if you grow legumes, you can make nitrogen. And that's the only nutrient you can make on your farm. Okay. And you might say, well, the cows shit out all kinds of nutrients, which is true, but a lot of those you purchased, right? In grain. So, you can make nitrogen, but in order to do that, you've got to create a soil environment for the legumes. And that means the pH needs to be above 6.5. Okay. So this soil test shows 6.6. So I said that the pH impacts a lot of other things. And one of the things that impacts immensely is the availability of all the other nutrients. So if your pH is too low, you can look to the left here on this slide, you can see that the level of those nutrients starts to decline in some cases, right? So if your pH is below 6, the level of phosphorus goes way down. So doesn't the level of potassium. Okay, nitrogen availability also starts to go down, calcium, etc. So keeping that pH again in that sort of slightly acidic, which is just below 7, is optimum for the other nutrients as well. Okay, so sometimes you'll notice if you lime and then you take a soil test after that, all of a sudden your phosphorus levels start to go up because you've released phosphorus that was bound to other nutrients. Okay, so phosphorus can get bound to acids that make the soil acidic, right? Now, it's the same thing on the other end of the spectrum. So if you start getting pHs way over 7, the same thing happens. So what's really going on in the soil is these nutrients get bound up by the bases, or they get bound up by the acids. So especially nutrients like phosphorus. So you want to make sure you keep that pH in that optimum range. The other thing with pH that people probably don't talk about or think about is that the pH of the soil also really impacts the microbiology of the soil. So you guys, whether you realize it or not, you rely on all the bugs in the soil to break down manure. So most people here have plenty of that, or maybe not, but you're relying on the soil life to eat the manure and release the nutrients to your plants. In order to have a biologically active soil, the biology that you want also need a pH over 6. Okay, so efficiency, rapid cycling and breakdown of manure and manure nutrients really relies on the biology in the soil. So you want to keep the pH up for that reason as well. The primary conversion of nitrogen that occurs in the soil so that your crops can get nitrogen is done by 2 bacteria. And those bacteria like pHs over 6. So again, if you're keeping the soil too acidic, you're not going to get efficient conversion of nitrogen into plant available forms. So lime your soil. Some of us older folk remember, that people used to do that all the time, whether they needed it or not. And I feel like it's one of those practices people have kind of gotten away from. I don't know if is it less available? I'm not looking at you because I'm considering you in the old folk category, but I'm just thinking that you might have some experience around this. I consider myself in that too, but yeah, I mean, I feel like when I first started coming to classes, people would just be liming. That's just something they did regularly every few years. I don't see that as much anymore. And most of us are on soil types that actually do sort of require regular liming to keep the pHs up. So we're on soil types that are naturally acidic because they used to be forest. So keeping that pH up can be done by adding manure. That helps, actually. It buffers the soil. But for a lot of places, you need to be liming, okay? Okay, so we're back on the soil test. Got to zoom in here. And you can see below the pH, there's a bunch of nutrients listed. And it says they're modified Morgan extractable ppm. So modified Morgan's is the reagent that's used to extract the nutrients out of your soils when they go into the lab. And it's the extractant that works for us, okay? So this is a really important point because all of our recommendations that are made are based on this extractant. So that's why you are required to use a modified Morgan's test, it's called. And it doesn't have to be done by UVM, but that's what you have to use to create a plan. I think nowadays, most people do that. It was developed here in Vermont and other places in New England because we have acidic soils. So it's really meant to be able to measure the level of nutrients with our specific soil conditions. Okay, so below that you see macronutrients: phosphorus, potassium, calcium, magnesium, sulfur. So macronutrients just mean they're the amount that the plant requires is large, okay? You need a lot of these to grow crops. Now, you don't think about some of them like sulfur, magnesium, calcium. We're mostly focused on nitrogen, phosphorus, potassium, but all of those macronutrients are required by the plants in larger quantities. So that's what makes it a macronutrient. All right, so then you see the value found. So phosphorus value is 3.9 parts per million. So you're like, okay, that's good. Is that a lot? Is that a little? And then you see next to it has an the optimum range. So remember I said if you get in that optimum category, that's good. And so to be considered optimum, the phosphorus level should be between 4 and 7. All right, and it's not necessarily an arbitrary amount, but you kind of think, is it, well, if it's 3.9, am I good enough? You know, if I 7.1, now I'm high. Oh my God. So, you know, you got to think about it a little bit. If you're on the low end of medium versus the high end of medium, when you're thinking about, you know, what you're going to do. So then you can see for potassium, this is at 85 and optimum is between 100 and 130. And then you look back up at the table and you can see, yeah, I'm not in optimum. I'm not in those ranges. I'm right, you know, below that in medium. Okay, so those are really, and magnesium also has an optimum range, but none of the other nutrients really provide optimum ranges. Okay, it's just those few. Why is that? Well, you know, the research hasn't been done. We don't know. We don't have an answer for you, basically. So we can't tell you what's optimum if we don't know. So for the other nutrients, we give a average, like what is the average for the state? So if you're way below the average, you might think about using some kind of fertility source to bring that level up. And that's something that you'd want to really probably talk to us about before you went out and kind of spent a bunch of money on something. Okay, so below that are the micronutrients: iron, manganese, boron, copper, zinc, sodium, aluminum. So micronutrient doesn't mean it's not important, right? It just means that the crops require these. They are essential nutrients to grow crops, but they require them at dinky amounts, okay? So when you're looking at a recommendation for boron, we're talking a pound per acre. When we're talking about a recommendation for nitrogen or phosphorus, we're talking 50, 100, 150 pounds per acre. Okay? It doesn't mean that boron is less critical to the plant, but it's needed in much smaller amounts. Now, you know, I work with some farmers that always add a micronutrient pack, you know, when they grow corn, let's say, or they try to put micronutrients on various fields. Generally, you know, because we use manure on most of our fields, and whatever you feed your cows and they don't utilize is in the manure, we generally do not see a lot of micronutrient deficiencies on our dairy farms, generally speaking, okay? Because of that. If you have a field that's light textured, you know, super sandy, haven't had manure there in a really long time or ever, you're growing some certain crops there that are really sensitive to micronutrients, these levels don't look quite right to you, then yes, we should definitely think about figuring out how to get some of these micronutrients onto your farm. But it's hard if you're not using any other kind of fertilizer, because how do you apply a pound of micronutrients to an acre, right? You go out with the, so I was going to say a flour sifter. I mean, like, what do you do? So that's where some, you know, it gets a little bit difficult to figure out, especially on our organic farms where, you know, you're not generally buying tenders of fertilizer or anything, and there's not, you know, what's the carrier you're going to use essentially. Now, a good source of micronutrients that we do have available to us is wood ash. So I know a lot of people like to use wood ash. I know it was sort of more readily available in the past. I don't know how available it is now, but wood ash is burnt wood, and what isn't burned off is what's left in the ash. So it's packed full of micronutrients, and the micronutrients that legumes in particular really like. So there's a lot of boron in wood ash, and manganese and molybdenum. It also is high in calcium, so if you need the lime, and it also is high in potassium. So most people that use wood ash or have say, wow, I couldn't believe how much clover was in that field after I put the wood ash on. Well, that's why, because you've just given it exactly what it wants. All right. So wood ash is a good option for micronutrients. Okay, so let's see what I'm supposed to do next. Got through that. Aluminum. So aluminum on this soil, I bet you guys up here, you probably have higher aluminum levels if you have your soil tests. So different parts of Vermont have different parent material, essentially, how the soils are developed. And much of Vermont is old forest soils, and they're really high in aluminum. And aluminum is an acid. So if you have soils that are really high in aluminum, they tend to also have lower pHs. Okay. The other way that you would get lower pHs is generally from hydrogen, right? Which we get hydrogen sometimes in our soils from using commercial fertilizers. Or sulfur. So if you're using ammonium sulfate as an example as a fertilizer, that sulfur acidifies the soil pretty quickly too. So if you have high aluminum levels, there's a lot of acid in your soil, and you likely might need to lime. Okay. Now, I guess I'll talk about this later. Soil organic matter, 3.3%. It's kind of low. You actually, for most of us in Vermont, you should be at least at 4. That's the state average is 4.2. So you really, they're really, unless you're on sand, you know, you really should be able to maintain a pH over 4. And if you're not there, then, you know, let's think about what's going on there, especially with the amount of manure application we have in the state of Vermont. You should be able to keep the organic matter levels up. Now, I will say, just because you have high organic matter levels doesn't mean that your fields are productive. So, you know, I'll have some people say, I got an organic matter level of 8, but this field is the worst field that I have on my farm. Okay, so organic matter, and we'll talk about this in a couple of classes, is really critical to the functioning of the soil, but different types of organic matter do different things. And, you know, the newly added manure and organic materials you add to those fields is what cycles and makes productive crops. Okay, the old organic matter that's there helps to build the structure of the soil, you know, and things like that, that make it permeable, gives it that black color, but it doesn't feed microbes and crops. So you can have a lot of organic matter and it can be tied up essentially. So high organic matter doesn't mean always productive crops. All right, so the next thing is the effective CEC, which is the cation exchange capacity. So what the heck is that? All right, so I don't know. You want to take over now?
No.
Okay, well, you offered before. I'm just gonna go for it.
Be a short class.
All righty. I'm sure everybody would like that though. You're like, dismissed. We're done.
When's lunch?
All right. Cation exchange capacity is the ability for your soils to hold on to positively charged nutrients. So you can see in this little picture here, the soil has these negative charges. So soil, clay in the soil, and some organic matter has negative charge. Did you know that? It's fascinating to me. If you have a sandy soil, pure sand, no charge. Okay. So when we say sandy soils are leaky, they leach because there's no charge and there's nothing to hold on to the nutrients. So they just go, I don't know if that's actually what they do, but in my mind, down through the soil, just like that. Nothing to hold on to them, they just go. Okay, so if you have a sandy soil and you want to hold on to more nutrients, what do you need to do?
Clay.
Clay. I know some people that would bring you some. Good answer. Yes. I mean, you want to add something that has charge. But for most people on sandy soil, that would be adding manure, right? Adding some kind of organic matter that will create that charge. So here's these two examples. You have a cation exchange capacity of 25, and here's this other soil where it's only 5. So this is the difference between a soil with a high clay content and a low clay content. So lots of charge over here and not much charge over there. Okay, so that's why we also say clay soils are really fertile because they hold on to all those nutrients, but boy, they're a pain to manage, right? And the sandy soils are a little bit easier in some ways to manage, but they can be very expensive to take care of because they don't hold on to nutrients. You have to manage them different. All right, so in the middle here, you see all these positively charged nutrients. So hydrogen, which is our acid, right? And aluminum also that's not here, they have positive charge. So if you have a lot of hydrogen or aluminum, they bind onto those sites. Then calcium has a positive charge, right? Magnesium, ammonium, so there's your nitrogen, sodium, and potassium. Now, I said before that potassium leaches, right, pretty readily. And part of the reason it leaches pretty readily is because you see how that one only has 1 plus and the others like have 2 pluses? And aluminum actually has 3 pluses. So that's the valence, it's called. I'm sure y'all remember this from high school chemistry, your favorite subject that you've tried to forget about. But you know, essentially the more plus signs there, the stronger it's held on to the soil. So hydrogen, potassium, they're just sort of loosely bound to the soil and they move onto and off of those charges really readily. Okay, so that's why potassium can leach pretty easily. Calcium, magnesium, those are held on more tightly, and aluminum is held on the tightest, okay? All right, so just go down, here's this visual. I created all on my own, I know, I should be an artist. I know, good job, right? That's what you're thinking. I smell surprising amount of time on that circle. But you can see, so here's your soil, and you can see all the negative charges, and you can see the different nutrients that are held on by those charges. So the more calcium, okay, on those negative binding sites, the higher the pH is going to be. Okay, calcium, magnesium, potassium, they're all bases. They make the soil basic. They drive the pH up, right? So if you're on a soil that has high aluminum, then more of these binding sites will have aluminum on them. But what that also means is that the pH goes down, right? Because if there's more aluminum, there's less calcium, less potassium, because aluminum is really strong. It basically can outcompete everything else for that space. So what you really want are, you know, potassium, you want calcium, magnesium, ammonium on those binding sites in a certain actual distribution, which we'll talk about in a minute. So how do you get rid of the aluminum if you have an acidic soil? What would you do? We already talked, I already gave you the answer. That is one thing you could do. Liming, thank you. Okay, good. I know you're not going to fall asleep because I am right here. If you do, you're gonna have some problems.
Okay,
Okay. I mean,
awesome.
yeah, I'm just letting you know.
Yeah.
I did, yeah, I'll kick you a little bit, just a
Okay.
tiny bit. Okay. I'll try to end before noon, so the after lunch sleepiness doesn't kick in. All right. And if we're not having fun, why? Why should we be here?
Exactly.
I know. Okay, so we're gonna put the lime on. Now, if you have a lot of aluminum, it's held on really, really tight. So you have to actually add more lime. You have like basically brute force. So you have to overwhelm the system with way more calcium than aluminum to get them off. So if your soil is acidic from aluminum, you might need 3-4 tons of lime. If your soil is acidic from hydrogen, 1 ton of lime, because hydrogens come off really easy. Okay. That's the story about liming. So here's the reaction, and this just shows, oh, that's annoying. Let me get that. Oh, wait. You know, this shows liming with hydrogen. So you have hydrogen stuck on the soil particles. You add lime, which is calcium carbonate, and then you get this reaction where the calcium disassociates from the CO3, and essentially the calcium goes on to the soil, and the oxygen binds with hydrogens to make water, and then also some CO2. So that's basically the reaction. It's different with aluminum, but same concept. All right, so we're back here. Now on the bottom, so this soil has a cation exchange capacity of 14.1, which is pretty high. Usually, you know, you want 10, at least 10 to 12. It's a little bit harder to get on sandy soils. You know, you might be around 8, but the, you know, higher that level is, it means you usually have more clay or you do have higher organic matter levels. So on the bottom, it shows you base saturation %. So this actually tells you of all those binding sites on your soil, what percentage of them have calcium on it? What percentage of them have magnesium, and what percentage of them have potassium? So if I was well, I am looking at this. It says that 91.9% of the binding sites are calcium. So immediately I would think to myself, the pH must be good on this farm because it's mostly calcium. If that level was 50%, I would assume that you need the lime. Okay. So we look at the whole soil test to essentially make recommendations. And then you see the potassium is 1.6. You know, we really want that level a little bit higher, over 2. And you look at your soil test and it says, could use some potassium. And then it says the magnesium here is 6.5. And it should be between 10 and 30. Well, that doesn't really make sense. Does that make sense to you? The magnesium levels are so high in this soil. Why is there not more on the binding sites? Because there's so much calcium, and calcium is stronger than magnesium, actually. All right. So that's the soil test. You can get a lot from it. It is just, you know, it's, I don't want to say it's just a tool. It's an important tool, but you have to, you know, use everything you know about the farm and how much manure you have and money you have to spend to then take them and put them into practice. You know, where do you put your effort and what do you use? So on the bottom of the soil test, usually you get a recommendation if you filled the form out properly and told the lab what you're growing. You know, it'll give you a recommendation based on your soil test. And again, it takes into consideration all of the things I just talked about. It takes into consideration the pH and the cation exchange and the base saturation, and then all the different nutrient levels to come up with some recommendations to meet the needs of the crop. But what it also will do, which people don't usually realize, is that if you have low levels of nutrients, it adds extra to start to bring the levels up slowly over time. Okay. Usually if your fields are really low, you're going to need hundreds of pounds of everything. And most people, you know, you can't really afford to do that. But what the recommendation is doing is trying to build the soil up. So eventually you get to optimum over time. But, you know, if we're trying to figure out economically what to do, you know, then we really need to think about, well, what is it the crop needs now so that we can meet that need, and then think about what else we can do. Okay. You can see there's a lime recommendation that will show up if you need lime, nitrogen, phosphorus, potassium. It'll give a general recommendation for boron as well, if you need it, or zinc, if you're growing corn, also if you need it. And I think that's about it. Any questions? All that? It's a lot. Clear as mud. Great. Moving on. All right. I don't know why I put this in here, but just again, shows you the range of pH and the best range for crops. So that's what we're trying to hit.
And adjusting your pH can fix your micronutrient problem.
It could help. It could make it worse. It could make it better, you know. Yeah, you saw in that graph that it can help and can hinder. Okay, so then there's problems with really acidic soils, problems with really alkaline soils, some of what you were just mentioning about different micronutrients getting tied up or becoming too toxic, etc. Okay. All right. And this is what I already talked about with nitrogen and what the legumes need and what the bacteria need to be able to thrive, right? So they need a pH above 6.5. All right. And again, soil pH impacts phosphorus. So low pH ties up phosphorus to aluminum and iron, and when you lime, it'll release the phosphorus. Same thing on the other side. Too much calcium can bind up phosphorus as well. And with potassium, if you increase the pH, you'll release potassium as well. It gets complicated how it all happens, but it does. All right. Do we need a break? I didn't know there was lunch ticket. Yeah. All
You
right.
better get some cold water.
I know, I have it. I know.
Is it cold though?
Yeah, well, it's as cold as it is over there. I know, I've had this darn cough for like 3 weeks. Maybe if I stop.
Talk for like 30 seconds.
Yeah.
What does everyone think?
Yeah, right. Exactly.
But let's just say, I mean, I was always told that, 2 tons per acre of lime at a time.
Is enough. Yeah, you don't want to put on
You
4.
go in there
Yeah.
with 3-4 tons, it's number one.
You'll kill the plant.
Yeah, and number two, if it rains at all, at any amount, it'll leach it out.
Yeah.
Just
Yeah,
run
yeah.
it off.
No, 2 tons really at a time. If you have a recommendation
If you
for
are
4,
incorporating.
you gotta split it up. Yes, especially if you're not incorporating. Yeah, I should have said that.
I actually did it, I spread like 1.5 tons and I aerated, that was.
Yeah, especially on grass ground, because it takes a while for it to get down there. Okay, we're taking a break here to do our lunch tickets.
Nitrogen to carbon ratio is important for organic matter.
All right, so let's keep moving along here. So this graph image thing, table, picture is really, I think well, I guess I didn't really mention this before, but phosphorus it has a high affinity for other nutrients. So it doesn't like to just it doesn't like to hang out in the soil by itself. So the minute you add phosphorus to the soil, it actually can get bound up really quickly, depending on your soil type. Also depending on how high your phosphorus levels are. So if you have a low pH or a high pH and you have a lot of calcium, iron, aluminum, and your soil test level says you need phosphorus, okay? And it also says you need lime. What most people are going to do is they're going to go and they're going to put the phosphorus on. And what will happen is that phosphorus gets sucked up by the aluminum really, really quickly, like within a day or 2, right? So you add that phosphorus in the form of fertilizer or manure, and immediately the available phosphorus gets bound up. So if you grow corn, let's say one of the reasons we want to put phosphorus fertilizer right near the seed is because if it's not right there, right near that growing seed, it could easily get bound up really quickly. So we want to give that phosphorus that you're putting on the best chance of getting to the plant roots. Now, the other thing about phosphorus that's really interesting and doesn't make a lot of sense to people is once you put it in the ground, wherever you put it, it does not move very much. So then people say, well, why do we have this phosphorus problem if it doesn't move? So I read this study, I think last year or the year before, where it said, the amount, like you put phosphorus in one spot and it may move an inch, during a whole growing season with our rainfall. So it's pretty immobile, which also means that in order for plant roots to actually access it, they need to grow to it. Like the phosphorus doesn't move to the plant. The plant actually has to move to the phosphorus. which again is why, when you have seedlings, and, in our case, a lot of time we're talking about corn in this case, you want to put that phosphorus right near the seedling so that it has access to it. If you have really, really high phosphorus levels, it's a totally different story, okay? Sometimes, believe it or not, those binding sites can become full, which we actually didn't think could happen 30 years ago. We had no idea that the soil could sort of max out in its ability to hold phosphorus. And when that happens, then you can actually have leaching potentially of phosphorus, into the groundwater. And that really is sort of something we did not realize before. Our assumption for a long time was that phosphorus didn't leach. So how does phosphorus leave your fields if it's not mobile? It leaves attached to soil, right? So I just said it binds onto these soil particles. And if you're losing soil from your fields, erosion, it has phosphorus bound to it and other nutrients. So that in Vermont is one of our biggest issues, is that if we can really minimize erosion coming off from fields, we can really minimize the amount of phosphorus that potentially can make its way into the water. But that is the primary way that we lose phosphorus from our fields. There are other ways as well, and we'll talk about those here in a minute. All right. So I mentioned this last week, and again, in your nutrient recommendation for field crops booklet, this information's all in there. There's some page in here, I don't remember. It's on page 11. If you wanted to actually see it up close. All right, so if you have a grass field with less than 30% legume, and you want to get 3 to 4 tons of dry matter, which is, we call it medium level management here, but that's good, actually really good yields, okay? Then you need to add 50 pounds of nitrogen basically for every ton of dry matter you're removing from the field, right? To replace that, to get that grass to keep producing. So over an entire season, that adds up. And you can see if you're trying to get 5 tons or more an acre, you need hundreds of pounds of nitrogen. To supply that with manure is a lot of manure going on those fields. And I can pretty much guarantee you, if you're writing a nutrient management plan, you are not going to be able to do that and also protect the environment. Okay, that's a lot of manure. So if you go down below and you see a grass legume mix, so when you start getting above 30% clover, whatever you're growing out there, the amount of nitrogen you need goes way down. Okay, so now you're talking about, somewhere between 40 and 80 pounds of nitrogen needed to support the grass. And you don't want to overdo it, right? Because you're trying to make sure you keep those legumes as well, right? So we'll talk more about this next week. And you can see if you have more than 60% legume, you don't really need to add any nitrogen. So your legumes should be able to feed the grasses that are there. There we go. Okay, so these are where the recommendations for phosphorus come from on the soil test. I mean, there isn't a person sitting in the lab looking at this table exactly. There's, a calculation, but if you needed to make your own recommendations, you could go to your booklet, like I talked about, and you could go to this table, follow the directions, and make your own phosphorus recommendations, okay? So when we make a phosphorus recommendation, there are a couple considerations, and you can see to the left, the first one is how much aluminum is in the soil, right? Because I already said, if you have a lot of aluminum, it ties up the phosphorus. So the higher aluminum, generally, the more phosphorus you're going to need. especially if the levels of phosphorus in the soil are medium or low. Okay, so you can see with high aluminum at 120 parts per million and low phosphorus, you're going to need 120 pounds of phosphorus to meet the needs of the crop. Now, if you have hardly any aluminum and you have low phosphorus, you can see that level gets cut in half. Now, why is that? Because of what I just showed you in that other slide. When you put that phosphorus on the ground and you have a lot of aluminum, you're essentially giving up half of what you apply to the aluminum binding sites, right? And then the other half is allowing you to give it to your crop. Okay, so taking care of that pH is really, really important, especially when you have these low levels. Okay, so here's potassium. And again, I shouldn't say just another table. There's a lot of work put into these tables. Now, potassium levels, if you have low soil test levels, you can see even to grow corn or grass, you need a lot of potassium. That's, again, it's a macronutrient, right? So if your levels are low and you're trying to grow 20-ton corn, you need a couple 100 pounds of potassium and a couple 100 pounds probably of nitrogen, you know? So it can get expensive. And what I see people doing is kind of one or the other, not a good strategy, okay? Crops need all of the nutrients. So if you're just giving them one of what they need, it's still not going to optimize yield. You're actually better off to sort of divvy it up. So they're at least getting something of what they need.
I don't think we have that.
You don't have this packet? Should be in there. I think it's in the either references. I guess you couldn't do your homework last week. You're supposed to read the whole darn thing.
40 years ago, I did the homework. I don't
You
think
didn't
I'm
do
gonna-
homework
I don't
40
think
years
I'm gonna
ago?
start now.
You're not turning over a new leaf?
Nope.
All right.
See this?
You don't see it in here?
No.
No? All right. It is, like I said before, it's a good document. It's too bad you don't have it. I know. Oh, there it is. Yep. It's kind of
Very
hidden.
last thing,
All right.
or first from the back.
Now, there's a lot of other details in here on recommendations that we'll try to get to in other classes. But again, if you're wondering about, you know, should I be putting zinc on my corn, it will outline how you would determine if you need zinc for your corn, if you're deficient. Same with boron, same with magnesium. So again, it's a really good document. Okay, now moving on. All right, so we've talked about a lot of stuff. And I'm almost getting overwhelmed myself. I know, it's hard to believe. But we are gonna keep going because it's not lunchtime yet. And we're gonna talk a little more about phosphorus because at least in the Champlain Valley, which you are not in, it is the hot button topic there because of Lake Champlain. And, you know, because we live in a dairy and livestock centric state, we tend to have plentiful amounts of phosphorus because we have manure. And because, as you've already learned, phosphorus doesn't really move out of the soils like some of the other nutrients do, it can build up over time. So whatever you're putting on, if the crop is not directly removing that, or you're losing a lot of soil, right? Then you're building up phosphorus. So if you're putting on in any given year more than what the crop needs, the rest of it just stays there forever, for a long time. So you do that on most of our dairy farms for 100 years, over time, those levels go up, and so sometimes there'll be people that take this class that have a high phosphorus level on the soil test and they just cannot figure it out. They haven't put manure on that field for 20 years, but that farm was owned by somebody else, 20, 30, 50 years ago, and the levels are still high. So once they get really excessive, it is very, very difficult to get them back down. Okay. Because of the fact the only real way to move that phosphorus out of the ground is to take it out through plants. The other way is, to loose topsoil, which is what we're trying to avoid. So this is, it really is sort of I want to say a Vermont, any livestock kind of centric area deals with this, right? Like phosphorus loading and often water quality issues because of phosphorus, where the rest of the United States needs phosphorus, right? So most places are trying to find sources of phosphorus. And, if you haven't heard, apparently the phosphorus reserves that, are mined for phosphorus fertilizers are going to be gone in 50 years. So we are sitting on gold mine. We joke about this in Lake Champlain, right? That's right. You just start dredging out the lake for phosphorus fertilizer. So we don't know it yet, but yeah. So a lot of people struggle to get enough phosphorus fertilizer. And my in-laws live in Iowa, and my father-in-law will go to these kinds of meetings, and fertilizer prices are expensive everywhere. And they now are telling them, can you find a dairy or a beef farmer maybe that you could partner up with and get some of their manure? So, we are lucky in a lot of ways, but we have to learn how to manage, the phosphorus and the phosphorus loading so that we're protecting, the area around us. Okay. So as I said before, the amount of available phosphorus is pretty low in the soils relative to what is actually there. So what you see on your soil test is the little green box. What you don't see is the red box. So if you again have excessive soils, then you already have way more than enough available phosphorus, but there's also a lot in reserve. And that's why it kind of takes so long to draw those levels down in a soil test, because there's a lot there that we're not measuring. Okay. So it does build up over time. So we already talked about phosphorus kind of binding really quickly. And in some ways, this is a little bit what has gotten us into trouble in a way, because, back in the old days, and I hear farmers say all the time, the government paid us to put phosphorus on the fields. You were taking waste and putting these phosphorus all over the place, which is true. And I think, part of it was because we were really deficient in phosphorus. And so people were just putting on a lot more than what they needed just to meet the crop demand, like I was showing you before. But again, over time, that excess phosphorus that the crops weren't utilizing just, it just keeps building up over time. All right. So again, what we've added in the past is 2 to 4 times more than what the crop actually needed. So again, over time, keeps building up. All right. And then, when we add manure, because we generally need more nitrogen than we do phosphorus, we often are trying to meet the nitrogen needs of our crop because we have all this manure on our farm. Why wouldn't we do that? And so what ends up happening again is that we're adding more phosphorus than what the crop needs to get more nitrogen. Okay, so here's an example of that, kind of what's happened over time. So you can see the manure content here, the nutrient content of the manure is 15 pounds of nitrogen in every 1,000 gallons of manure. and 8 pounds of phosphorus. So there's about double roughly, and in some cases triple the amount of nitrogen in manure than phosphorus. Okay. So a standard corn recommendation is about 150 pounds of nitrogen, 40 pounds of phosphorus. Okay. So, well, nitrogen's expensive. I'm going to put on as much manure as I can. So I put on 10,000 gallons. Good. I don't need to buy any nitrogen fertilizer, but I've also put on 80 pounds of phosphorus, double what I needed, which again, in the short term, not that big of a deal, but you do that year after year after year, you got 40 extra pounds of phosphorus over 20, 30, 40 years, it just builds up. All right. And the fact that we actually import grain onto our farms adds to that problem a little bit, because we're importing more phosphorus onto our farms than we're exporting. Okay, so the nature of our system here in Vermont, we're not like Wisconsin, where those farms grow a lot of their own grain, right? We buy our grain. We don't feed grain, one or the other. There are some people starting to grow grain, but most people buy it. Okay, so what ends up happening is a buildup. So here's a phosphorus budget for a farm. This was done in Vermont and New York many, many, many years ago. It might have changed slightly. And actually we work on this a lot to try to bring people's balance closer. But you can see adding fertilizer and other nutrients, feed, which is grain for most people, and bedding, you know, that all goes onto the farm. And only 43% of it goes off of the farm for most people in the form of milk, sometimes in crops, sometimes in, you know, beef. Okay. And 57% of that stays on the farm. So we have to manage that and try to minimize that buildup as much as possible. Okay. Now, interestingly, like I said before, phosphorus doesn't move that much. And here's some soil depth data that was taken, I think this was in Pennsylvania. So you can see the red line is where a farm was adding 110 pounds of phosphorus per acre per year in the form of manure. And then 90 is the blue line, the light blue line, 40 is the yellow line, and the dark blue line is no manure. So you can see almost all of that phosphorus is in the top 10 inches of the soil. So it just accumulates right on the surface, which again it also makes it a little more dangerous to the environment because it's sitting right there. And that is the part that we lose again in erosion mostly. All right. Okay, so let's get to the P index so we can break for lunch. 11:38. Okay, so we need to consider the risk of phosphorus loss. We're going to use the P index to do it. That's in Go Crop, but I'll show you how it works. So with the phosphorus index, what we're really looking at is the movement, the transport of phosphorus. So how does phosphorus leave the farm? And I've already said this, I don't know, probably 10 times. Okay. You have two types of phosphorus that are leaving the farm. The primary one that we see in most cases is phosphorus stuck to soil. And we lose that in the form of erosion. That is called sediment bound phosphorus. All right. The second type of phosphorus that we are at risk of losing on our farms is dissolved phosphorus, which is basically phosphorus in water. Okay, so dissolved phosphorus, when you apply manure, you have available phosphorus in manure. that phosphorus might get into water and then we get a rainstorm or something and it moves. It's not attached to soil, it just moves right across the fields. There's also, there's also potential leaching that we talked about, but that's again, pretty rare. So what we're going to measure with the phosphorus index is the potential to lose sediment bound P and also the potential to lose dissolved P. Okay, so we can minimize erosion through different practices, right? Cover cropping, rotations, all the things we talked about last week when you were looking at your soil loss numbers from Russell 2. Do you remember that? How do we stop phosphorus in water?
Make it infiltrate into the ground.
It's got to go in the ground, right? So we, it's a requirement to have 25-foot buffers. And so what those buffers are going to do is they're going to slow down the water. And if there's any sediment in the water, it's going to make it drop down into the buffer. But that water still goes across, generally across the buffer. And if there's phosphorus in that water, the buffer doesn't matter, right? So when it rains, it is critical for that water to go in the ground. That's really the only way to stop dissolved phosphorus. Now, when we have a 3, 4, 5, 6, 7-inch rainstorm, it's really hard to manage erosion and dissolved phosphorus. The best thing we can do to minimize that is to have really permeable soils. Okay, compaction becomes a real problem here. We'll talk about that more next week. All right, so let's get through all this. Skipping. All right, so I'm going to show you the phosphorus index and what goes into it. So essentially, we're looking at transport of phosphorus off of these fields and all the things that affect that. The crop that you're growing, the soil type, the erosion calculation that we looked at last week, the amount of rainfall, where you're located, the slope, all of those things matter. What crop you're growing, and then the soil test level. How much phosphorus is already in your soil and how high is the aluminum level, okay? All those things matter when we're determining risk. So at the end, once you run the phosphorus index, it's gonna either come up as low, medium, high, or very high. And those are all risk, right? Low risk, medium risk, high, very high. And they all have implications on management. So if you have a very high phosphorus index, you are not to apply any more phosphorus to those fields, period. Okay, so what we want to do is figure out, can we change management to take those fields from very high to high or maybe medium, okay, so that you're able to continue to manage those fields, hopefully in the way you want to manage them. But if something comes up as very high, we've got to do something. It's actually a regulatory requirement. Okay. Now, if you get a medium, if you get a low phosphorus index, basically you can continue to do what you're doing, right? You can apply manure to meet the nitrogen demands of the crop. So you can put on more than what the crop needs for phosphorus, okay? But realizing over time that could change. Now, if you have a medium level, you can also continue to add phosphorus to that field, but the amount that you add cannot exceed what the crop is going to remove. So remember, I said, if we're adding more manure phosphorus than what that crop needed, it's going to build up over time. So if you have a medium P index, we need to manage that. So we'll have to manage how much manure you're putting on that field or fertilizer to make sure it doesn't exceed what that crop that you're growing is going to remove. Okay, that's scary for some people. So let's look at what that means. All right, so here's a crop removal list. How many nutrients the crop removes. It's also in this booklet. You get up close view. Okay, so it's on page 23. All right. So if you have a medium P index and you are growing 20-ton corn. Okay. So if you go, let's go up to corn. It's the second line. Let's see if I can get my mouse out there. Okay, it's the second line. And it says that for every unit of yield, you remove 9 pounds of nitrogen, 4 pounds of phosphorus, and 11 pounds of potassium. So for a 20-ton corn crop, you will remove in the crop 180 pounds of nitrogen, 80 pounds of phosphorus, and 220 pounds of potassium. So again, if you get a P index that is medium, you cannot apply more than 80 pounds of phosphorus to that field. Okay. And that's actually, it's quite a bit of manure. So don't freak out yet. If you're going, oh my God, what am I gonna do? Okay. So I think basically at 8 pounds of phosphorus per 1,000 gallons of manure, you can see to that field, you could put on 10,000 gallons of manure and not exceed crop removal rate, okay, for 20-ton corn. But if you're producing 10-ton corn, that really changes things. So yields matter, right? So we talked before about you're going to have to be putting yields into the program, and part of that is to determine what the crop removal rate is. So we want you to use realistic yields. You know, we don't want you to say you're growing 40-ton corn silage so that you can put on, put on 30,000 gallons of manure. That's not realistic, but we want you to have realistic yields, really is what it comes down to. All right, so we got to get into Go Crop. We're going to go over our homework for this week, which is more than last week. So, yep. www.gocrop.com. You log in there. Okay, so you log in. It should bring you to your farms. And then you want to go work with this farm. I think that's what it says. Here we go. We're back here to the dashboard. And this week, we're going to be going to fields. So we're going to have you enter in all your fields. So basically, you're going to create your fields in Go Crop. So we got to go to fields. So you press fields. Go to the field. There it is. There's already one there. I made that one up last night. I was practicing. Or maybe Lindsay made that one up. Anyway. All right. So for every field, almost, okay, you're going to want to create it in Go Crop. So when I say almost every field, what do I mean by that? So now when you get your maps, let's say, or you have your maps now, or you get your maps from FSA, and they have every little field in one field, right? So you have this 2-acre field next to your 5-acre field, next to this 10-acre field, but they're all a hay field, and you manage them all together like one field, right? You don't actually manage them separately. Do not put them separately into Go Crop, because for some people, they do that and then they end up with 80 fields when they're only actually sort of managing everything as 50 fields, right? So take a little bit of time to just think about how you might, or how you already lump your fields together, okay? So you don't want to over lump, but you don't want to under lump either. I'm sure that makes perfect sense. But again, if you have, a bunch of fields right close together, you manage them all as one big hay field, you go out there, you mow them all at the same time, you spread manure on them, and blah, 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 blah. When you keep records, you're like, this is what I got off of this set of fields, then they should go into go crop as one field. Now, if somebody came out and took 4 different soil tests for those fields because, you gave them your maps and they went out and sampled every field because you didn't tell them that you manage those 4 fields as one, okay, then you could average those soil tests together. You could, just make sure you look at those soil tests, make sure they're not hugely different. They're usually pretty much the same if they're managed similarly. But you'll want to average them together or pick the representative soil sample to use, okay? So when you add a field, I'm going to go up here where it says add a new field. Click. Okay. It says field name. So this is what you call the field. Okay. So usually people they have names for their field over there, under there, back there, behind that. So this is where you would put your field name. Now, if your field name is the track and field number, that's what you use to identify the field, you can put that here, but normally you would just put whatever you call it. So I'm going to call this my field. Okay. And then it asks you for the size of the field. Okay. So how many acres is it? It's going to say 12. And then it says included cents. And I think Lindsay mentioned this last week. So you could put 2023, you could put when you bought it, and 20 or 1975 or whenever. It's sort of, I don't want to say it's irrelevant, but it just, it's not used. It doesn't matter what you put. Let's just put that. Just don't put a date in the future. Okay. So I'm going to say, this is the land I bought in 2003. Okay. And then it says ownership type. Do you own it or lease it? So I own that. And then it says the county that you're in. Now this is important because some of the information that you're adding in now is going to be used in the phosphorus index and in some of the other calculations that get done in the background. Okay. So if it has a little star near it, means you gotta put it in there. So this field, yeah, I'll go with Franklin County. And then any notes you want to add in about the field if you want. What does that say? You can complete each of these. Okay. So now I'm going to save. Saving. Is it doing it? Okay. So now I've created a field. There's a lot more stuff to do with those fields, and I'm going to show you the next set of things to do with it. But for your homework, in the absolute minimum, I want you to do the maximum, but I'm just going to say the absolute minimum is to enter each field in there, like I just showed you, which is not, it's not a whole lot of work. If you have a lot of fields, it's going to take you some time. Okay. So once you get them all in there, and you can do this next part as you're entering them in, or you can come back and do it after. Okay, I'm going to go back in there and you can see that I can scroll down. There's more, right? So there's a mapping feature in here where you can outline your fields. And this is not a requirement. You do not need to do this. but you can create your fields. Da-da-da. Okay, and where it is on your farm. There you go. There it is. So you just outlined it. Now where this sort of becomes, I would say, more handy is if you're using the mobile app and you've outlined your fields, you can see the outline of those fields on the mobile app and you can enter through those fields. Okay. So this also takes some time to do. So depending on how much time you have, you may not want to invest a ton of time in outlining all the fields. That's, again, it's not a requirement that you do that, but you can. Okay. So then it says soil type. So where are you going to get your soil type data? Off the soil fact sheets, which we don't have, but we do have something. I'm looking at you because usually the land treatment planners have a list of soil types. Oh, you do? Okay. All right. So you can get out your maps, right? You have your soil maps. And on those maps, it tells you what the soil type is for that field. Okay. Now, I like to use the predominant soil type. Other people use the worst soil. Well, so
Some people may use non.
yes, so you want, if you have multiple soil types in a field, use the soil type that best represents the field, okay? So then you want to select it from the list, which I can't see any of that, so I'm going to select the first one, which is great. And once you select the soil type, you can see all this other information fills in for you, which is great. Because in the old days, we had to fill it in separate. So, okay, so everything is in here that you need. Now it asks you for the water table depth. Is there a star next to that still? All right, so you got to put something in there. That is on the soil fact sheet. I'm just gonna put 1. It's not used anywhere in the plan, but you do have to put something there. And then it says depth to bedrock, same thing, that's on the soil fact sheet. I'll put something there. Okay. So now you filled out the soil information, so you can update that. Okay, that's the next part of this. So you've created a field, the acres, what you call it, and then you selected the soil type. Okay, you outlined the field. And now we're going to show you the last, I think it's the last part you can do in here. Oh, my field didn't stick, did it? All right. Now, why did that go away? You know why that went away?
It takes a little while to connect to Sergo,
Oh, I gotcha. Okay.
but it'll come back up. Yeah.
Okay. All right. So now it's asking you for more field details. And this information, a lot of it is going to be used in the P index, the phosphorus index. All right. So let's see here. Oh, there it is. Came back magically. All right. So the first thing it asks you for is the FSA track and field number. Now, if you are inspected by the state of Vermont, or if you're writing a plan to apply for, you know, an NRCS equip program or something like that, nobody knows my field, right? Or the field behind the barn or anything like that. All those fields are identified by the FSA track and field number. That's how the state looks at them. That's how the NRCS, the federal government, FSA. So we need to make sure that the track and field number is listed correctly for each field. All right. And so this is where you would put that. That's on the maps, or maybe you have a printout somewhere that was created for you. So this is track 124, field 12. Now, if you lumped fields together and it's all track 124, you could say, oh, it's field 12, 13, and 1. Okay, so now we know that you have taken those 3 fields and it's become one kind of management unit here in Go Crop. So that's where you would do that.
Can we group them by soil sample or like soil sample?
No, you cannot do that.
Okay.
Maybe you can. We can. Usually fields that get grouped are those that, you know, they're really close together and the farm is managing them as like one field, even though in FSAs, you know, reporting their mapping units, they're broken out as multiple fields. Okay. So then it asks you what the vegetated buffer width is for that field. What is the required buffer width? 25 feet, okay? You cannot put 0. Do not put 0. Okay, you can put 0, but don't put 0. You can do whatever you want. You can leave it blank, but yeah, in order for the whole thing to work, you got to put something. And if you put 0, 5, 10, 15, 20, 22, it's going to get sent back to you and say the required buffer size is 25 feet. So it's a minimum of 25 feet that you would put there.
What
It may
about the
be much
ditches?
bigger, but it can't be smaller than that. Okay. So the next thing it asks you is about the manure spreading setback. This is 95% of the time 0. Okay. It's not 25 feet. This is different than the buffer. Okay. The buffer is a requirement. You have to have a 25-foot buffer. The manure spreading setback is in addition to the buffer. So as an example, if you are along the Missisquoi, let's say, and you have a hayfield there, you have your 25-foot buffer, that's a requirement, but there's kind of a good slope there. And you yourself as a farmer says, I always set back more. Not only do I have 25 feet, but I actually set back an additional 25 feet because I really need to, okay? But there may be a regulatory requirement, but generally you're just putting 0, okay? And I say there may be because there might be a recommendation made to you by somebody that's regulatory that you have to have a bigger buffer there. But unless you've been told that, it's a 25-foot buffer with a 0 setback unless you're doing more or you've been told you have to do more, okay? So if you get confused, put 0. That's likely what it is. Now, what most people do, even after I've said this a lot, is they still put 25 because that's what makes sense, right? Intuitively, you're setting back 25 feet, but it's more than the buffer, okay? In addition to the buffer. And most people are doing nothing more than that 25 feet. Some people do, but okay. Does it have living vegetation in April? So if it's a grass field, your answer would be yes. If it's a cornfield with a cover crop, your answer would be yes. It's a cornfield without a cover crop, but you think it's weedy enough to justify it being a cover crop. I guess you could check yes. We'll leave that up to you, but it's really meant to capture cover crops in general in the P index. Okay, in the P index, if you say that you have living vegetation in the spring, it reduces your risk. Okay, so I'll let you decide if your weeds equal a cover crop. That's kind of up to you. So we'll just put yes. Okay. All right. And then it asks if it has tile drainage. So this means that it is system tiled. Not that you have, you know, you went out there and put in like one little tile line out there just for the heck of it. That's great that when we respect your honesty in reporting that, but this is really meant to capture fields that have system tile. Okay, and again, that will go into the P index and it modifies the risk. Okay, so most people, this would just be no. Do you have a sediment trap structure? If you have one, you know you have one. Okay, it's not. So most people it'll be no. All right, so then it asks your elevation, distance to stream, frequently flooded, end leaching index, tolerable soil loss, ooh, la, 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 a lot more stuff. Okay, forgot about all this. Okay, elevation. I live in Alberg, so we're at like 400 feet below sea level there. We are. Well, not below sea level, but the elevation, we used to get a topo map. I don't know where it is now. Where's the, where's,
It's not on the thing.
I don't know who to stare down
It's
here.
not on the
We're at
purple sheet.
800 feet, right?
I get it from RTIS.
Where did they get it from?
It's not-
I think Newport's like between 700 and 800.
It does really matter because it really plays into the P index. So we'll need to make sure.
There was a
Everybody has-
requirement on one of the, on the spreadsheet, so.
Okay, usually the land treatment plan has a printout that includes the elevation of the fields because we stopped giving topography maps. So, all right, so you need the elevation and then you need the distance to stream. Okay, how far are you from its surface water? Okay, you're never 0 feet from surface water. Why? You gotta have a 25-foot buffer, okay? So even if your field's right on the river or the lake, it's still 25 feet from water, right? Okay, usually for most fields, you're quite a distance from water. All right. Again, usually there's a printout with the distance to stream.
What about ponds?
Ponds have a different requirement. Okay, so again, you know, if you're 500 feet from water. Okay, so let's say you have, I would put an example up, but I don't think I can manage to get one up on the screen. So we're just talk about it. Close your eyes, visualize this. Okay, don't visualize what I'm gonna say.
Don't close that door.
Yeah, not too long. Well, especially you. I got my eyes on you. I think. But anyway, so you have a cornfield. Okay. And the cornfield has a 25-foot buffer on it along the Missisquoi. So the distance to stream for that cornfield is 25 feet. Next to the cornfield, there's a hayfield. Okay. And that hayfield is how many feet from the stream? Quite a few. Got a whole cornfield in between, right? But because well, no, now I might be saying this all wrong. Well, I can't put up my example. Just put down the distance to stream. If it's over 300 feet, you don't get any credit for being over 300 feet. So if you're, you know, not right on the river and you're more than 300 feet, just always put 300 feet. We'll keep it at that. Okay, so there's a lot of nuances in between. I can't get the examples up, but I will at least show people in this classroom after we get off of here. And hopefully Lindsay and Sarah can show people, you guys can show people the different images. They're in the book, but I can't get it up on the screen. So we'll put 25 feet here. And then is it frequently flooded? No. Okay, if it's frequently flooded, you'll have a map that shows it's frequently flooded. Nitrogen leaching index. Used to get a map. You don't get maps, so I don't know where it is. It should be on the list. It should be in your land treatment plan. Okay, and then your tolerable soil loss. So what is T for this field? And that's what you selected last week. Remember, you got your Russell 2 printouts and you were looking to make sure you met T. So T was the tolerable soil loss assigned to that soil type. Okay, it's not your predicted soil loss. It's what is tolerable for that field. I think this one is 5 tons. Okay, and then it asks for any other water quality considerations. So you can type in next to pond or something like that, or my neighbors don't like me or whatever. Okay. They're always yelling at me for spreading manure. Okay, so ideally, that's what we want to enter this week for all the fields. It's a lot, especially if you have a lot of fields. So in the lease, try to get the fields in with the most basic information and fill out as much of that soil information as you can. Because next week there's going to be as much work to do. So, and you really need to get your fields in there to be able to continue with everything else. Okay. So Lindsay is going to show us how to import your soil tests, which is a huge time saver versus entering in each one. So Lindsay, I'll turn it over to you.
Okay, so I think where I wanted to start today was just showing you what your, hold on, let me fix this. What your soil test results look like in an Excel spreadsheet. So I'm gonna fix this. So you got your lab ID, you've got a sprinkling of your results, like you see iron right after that, and then you have your custom sample name. And so that's the text that will be in there, depending on what you wrote down on your submission form or what the person who is taking your soil samples wrote down on the submission form. I think the other thing that's really, really important and is different this year is that you'll need to copy your CEC results into your ECEC column. So to do that, I'm just going to copy those using shift and my down arrows, using a shortcut Control-C, copying them, clicking into the cell underneath the ECEC, which is your cation exchange capacity, and then pasting that with my shortcut Control-V. So you can just kind of take a scan. Here is not a bad time to just kind of look and see what you've got going on, if these numbers in general seem like what they should be, what you should be looking at. So now I'm just going to save those changes. And then the other key piece here is that when you save this, you're going to, in order for GoCrop to accept it, it needs to be in a CSV file. So to do that, we're going to go to File, Save As. You're going to choose which folder you want it to be in. And then you can see that down below what we have are soil test results named. We have a Save As type. Right now, it's an Excel workbook, but we want to choose CSV. So we go to Save As type, we get a drop-down menu, and we're going to scroll all the way down here to CSV, comma, delimited. Not sure if that's exactly how you say that. You'll see there's some other CSVs down here. Just ignore those. We want the comma delimited. Delimited? I don't know, that one. So once you have that chosen, you got your location chosen, you'll click Save. I'm going to click Yes for this. I'm going to keep this format. So now you can close this. Remember where you saved it so you can access it later. And we're going to say, yes, I'm going to keep these changes again. Sometimes when you initially open up a workbook, it might say, hey, I can't save this. I can't make these changes. And at the top of the workbook, it will say enable changes or viewing, and you'll have to click that yes, or it will prompt you to click that. Okay, so now to import your information, I'm gonna make sure I'm in the right account here, which I am not. You want to go to your dashboard right here, and you're gonna scroll all the way down here to import data, and you're gonna choose new import. So then you have this form that appears, and you're gonna say, okay, I can either choose to download a template, and this can be useful if for some reason you did not use UVM's agricultural and environmental testing lab. You can still import your soil tests. And if that's the case, please get in contact with me or somebody else from Extension. We can show you how to use that template. But otherwise, you're going to say, oh, we got it from the UVM soils lab. And then it's going to prompt you to choose that file. I'm going to go to my desktop where I saved this. And I think one thing to point out is that oftentimes, right, you'll save your workbook and you'll save your CSV in the same file or the same folder, but GoCrop doesn't recognize the workbook, and so it will only show you the CSV as something that it can take. So I'm going to click that, the document we want to import, and we're going to click open. So then it's like, hey, we've got everything we want here. This is nice, and we're going to click next step. So here, what you can see is that we have these two results, and they perfectly match up with my, I'm gonna move this, with my name. So you can see if I come back here, hopefully I can go to back to configuration. I'm gonna scroll up here. So what happened here in this situation, I'll go back and I'll change one of the names to import this again, because I want to show you how to match field names. And I thought that I had, this is what I wanted to do. So sorry about the hiccup here. Now you get to see twice it getting saved as a CSV. It prompts a bunch to have it saved that way. All right, back here we go, new import. Coming back up through the UVM soil lab, I'm going to choose the file, sample test 2 this time. And now we have this custom sample name that's flagged, right? So what I wanted to show you here is that I have these two examples. One where I'm naming my field, a field name that I might use on my farm, like back there, my field over by the ditch. And then we also have sometimes soil samples are taken maybe not by a name that you're familiar with, but more by the FSA farm number. So GoCrop will try to match those for you. And if it's a 1-for-1, it will either do it by the FSA track and field number, or it will do it by the name you call it. But here you can see that I've misspelled my field in my soil test submission. And so GoCrop's like, it's not a complete 1-for-1. And so from there, we can choose from the drop-down menu which one that actually applies to. So on the left here, on the left here, we have our field names that are from our soil test report. And then we have on our drop-downs, this test names as we put into GoCrop. So this one, the top one was already matched for us because it matched the FSA track and field number with the one that we had in our soil test report. And here it didn't match because it wasn't a direct 1-for-1 on our soil submission form and our field. Then if we look down, you can see there's a number of nutrients like we saw in your soil test report that are reported, but GoCrop does not require. You can import them, like there's sodium, right? You can skip this column or you can include it. I would recommend that just for this first go around, just take it as it is. Like GoCrop's setting you up for success and what you need to put in there to meet state requirements. But you can see that it's looking at all of your columns in your soil test report, and it's only including the ones that you absolutely need for state nutrient management planning reporting requirements. So there's all those pieces. And now we're going to say preview with these settings. Again, we see this, we see how many soil tests we're importing. We see that there's 3 results, 3 nutrients going through. That means that it's taking in our cation exchange capacity, and now we're going to import them. And no matter if it's 2 soil tests or 5 or 15 or 20, it still takes a little bit of time. So we can see our little gears turning here. And we'll wait. Sometimes, and you'll see this in report generation, GoCrop will give you a countdown like 5, 4, 3, 2, 1. And it just keeps repeating that. So it's kind of a little bit of a fake out. You're like, oh, it's coming, but it just keeps on recharging. All right, it says we're good to go. It imported them. We're gonna close this and we're gonna double check that what we put in went to the right places. So again, we kind of looked at this last week, but we've got our side menu. We're in our dashboard. We're going to go to fields. We have our field list. And let's check out big field. We've got this information. We've got it mapped out. And now we have our soil test results right here with our pH, our organic matter, our CEC. And to see more information, you can either click on the blue dots here and see what you've got. If you want to make any amendments to this, you can click on this edit soil test and say, you know, I just want to add that I got this from UVM's AETL lab. You don't have to do this. I'm just throwing that out here. Sometimes I will mention though that, you know, let's say that you have a field that's 30 or 40 acres as 2 soil test results. You might put in there, oh, this is I'm going to average those 2 because I want the average of them to be what my recommendations are based off of. I might write in my notes like average of 2 results, or in a situation where you're looking at your fields and you're like, well, I really managed this one separately, but this last year we missed soil sampling it, but I have this other field that's really close by. That's the best case scenario we have for trying to approximate the nutrients that might be in this field. I might say, you know, in the notes, this is test results from, you know, field 22 or something like that. And then in your narrative, which I know you already looked at last week, you might write something in there saying, I know that we need to do this in 2023 to test this soil or this field soil.
I think it's also really helpful to put in who took soil tests to figure out how they were done.
Yes, say VACD or NRCD took soil test. You can also write that in your narrative, but these notes that you write in here or don't show up anywhere in GoCrop, like in any of the written reports. Like you'd have to go back to this specific soil test in the field to read what was written there. And I'm going to update my soil test, and that's it.